Okay, now members, we are going to see how do we use our formula. Now, equations that are having when their powers are 1, 1, when we have a function of cos and sine, in most cases we either use our formula or the formula. All of them are going to give you almost the same answers. Now, in this number, before you use our formula, you make sure that the angles on the two trig functions are the same. And also before you use the formula, also the angles on the two should be the same. But now we are focusing on our formula. So our formula is sort of in equations of a form of a cos theta plus b sine theta, where cos and theta are having first of all the same angles, and then there is power is times power and times power 1. That's there. Is that we are going to use always our formula. Then equations of this one, they are there. Now, we have either use the arrow formula in terms of sine or use the arrow formula in terms of cos. How is that we are going to use sine? In most cases, if you are given a question when you see that sine function value is starting, it's always better you use the arrow formula for sine. Then also here, sine, it's always use sine. But you know that whenever we expand it, you have to put this in mind that the sign in between in the function we are given is always determining the sign in between. You know, if we expand sine of two angles, multiple angles, always what the sign is going to be positive. That's why if we have sine of theta plus, it's always going to be plus the sign. Because if we expand this, we are going to get a plus. Now, always this is theta, the angle given is what starts here, then plus add this alpha. This alpha is an angle we are going to be seeing how we get it, but it's always acute. Now, you see, if we have a negative, if the question given, the angle between them, the sign is negative, then also this one for sine becomes negative. Because if you expand sine, you get a negative if the angle between, the sign between those two angles is negative. How do you get R? This R, you get the coefficient of sine, then the coefficient of cos, we square them, then we get the sum and the square root. How do you get this alpha here? Alpha here is always this function we are using, its coefficient goes down. So the sign the function I'm using is sine. So then alpha is going to be tan inverse of the coefficient of this function I'm using down, then this up. As simple as that. We ignore the negative because this alpha is always acute. When you come now to cos, for cos, when you expand the cos, if you have this as a positive, when you expand the cos, it's going to be negative. That's the difference when you're using cos. So cos always the angle here, the sign here is opposite to the sign here. But for sine, the angle here should be the same. The sign here should be the same. So that if you have a negative, then this one is always positive. That's it. So the same way we get alpha is the function you're using, its coefficient is always down. So note here, if you have cos, then the coefficient goes down. Then alpha is always acute as you've seen. Now we are going to solve this one. Let us see how do you use it. Now from here you first check, are my angles the same? You see I have theta and this is the theta, so the angle is the same. And you see this in this form now. Power 1, power 1. So there I can use our formula. So you see that now it's cos that is starting and the sign here is positive. It means that now what I'm going to use, if it's cos starts, it's better I use the function for cos. You can also use the sign, but it's going to be a little bit harder than using cos. You see, if this function is cos, then you start by using cos. So you say the solution, let R now cos, because cos is the function starting here, then the theta, the angle given. Because we have in cos, this sign is positive, then this one is going to be negative alpha equal to the whole of this. Why? Because when you expand this, you shall get a positive which we need there. Some people, the other method people use, they expand to compare coefficients. That's so called so, but this one is a shorter method. When you just need to know this, that you need to get your A, you need to get your B, and then simplify life like that. Now let us get our R. After using this, we can get our R from here. So from here, our A, if I compare, so my A is going to be 4, then my B is going to be 3. So now I can easily get my R my r will be the square root of x squared, which is 4, then plus 3 squared, and this will give us 5. How can I get my alpha? Said our alpha is always tan inverse of b over a, which will be now tan inverse our b is 3 over 4. Then here our alpha, the answer you get is 36. Two decimal places, 87 degrees. So I have alpha, so now I come back in this equation and I just substitute them. So my r is 5 cos of theta minus now our alpha, which is equaling to 4 cos theta by 3 sin theta. You start with first ignore this, you first ignore it always. Now, the reason why we use our formula, we don't want to use this expression. Now, so the order of this expression here is equaling a 5 there. So where there is this, I'm going to put my 5. So we have now 5 equaling to a 5. Why? Because from here, the order of this is equaling 5. So you see, if we divide through, we have our cos theta minus equaling to, if I divide through this side, and you have a 1. So can we get our answer there? Our theta minus 0.87 is going to be cos inverse of 1. And cos inverse of the 1 is 0 or 360 degrees. That's how we get the cos inverse of 1. Either 0 or 360 degrees. On this range, then can we take everything this side? You see, so our theta now is going to be, now we get 0, now plus 36.87, comma, then we are also adding this side, 360, then plus 36.87. So our theta is going to be 36.87. Now you see this one is out of the range. Why? Because when you add there, and add this to here, you have 396.87. And it's out of our range. So therefore, our theta is 36.87. That's how we have got our theta. As simple as that. Now let us come to this one. You see here, the angle is x and this is x, this is 2x, so angles are not the same. So our task is now to first convert them to be the same angle. Now you start this one, I can easily use, you start this one and say double angle or sine. How? You know that always sine 2x. Remember our sine 2x is always equal to 2 sine x cos x. So the order of this is now this, so that this angle is the same as this. So now from here, I'm going to be having now sine 2x plus cos 2x equaling to 1. And simple as that. So I have everything now. What happens after? Now I say this is sine. If sine starts, it's better I use sine. But now the sign here is positive. Meaning if it's positive for sine, the sign is the same. For cos, it's different. So here I say, let now my r sine, the angle we have now is 2x. Then plus, for sine, it's always plus. Alpha b now sine 2x plus cos 2x, like that. Now from here you can come and get to start the coefficient of a. From here our a is 1 coefficient here, and our b is also a 1. So now we can easily get our r is saying the square root of plus b squared, which would be the square root of, and so this will be root 2. So after getting that as our r, so we have everything. Now you can now come and get our alpha, which we say is tan inverse of a over, of b over a. The function here, a, comes down. So this will be now tan inverse of 1 over 1. And we see that our alpha tan inverse of that will be 45. It's always acute. That's why you don't go into other programs, because this alpha is always acute. That's why I don't go to the other angle of 225, because this alpha is always acute. So now, after that, you come and write this. So it's that the whole of this is root 2. So root 2 now, my sine 2x plus now my acute, which is 45, equaling to now sine 2x plus cos 2x. But now, in the question, note that the whole of this is 1. So I have now root 2. Then I have sine 2x plus 45 equaling to the whole of this from the question. Sine 2x plus cos 2x. Now for me, sine 2x plus cos 2x is 1. That's why I did this. I'm going to put 1. So can I divide? I have now sine 2x plus 45 equaling to 1 over root 2. Then you can get the inverse. Sine inverse of 1 over root 2. And now you see that this one is positive. So here, now you consider all the quadrants positive in the first and then the second. Sine is positive in the first and the second quadrant. So from here, my 2x plus 45 degrees will be equal to, in the first quadrant it's going to be 45. Then in the second quadrant we get 180 minus 45. That's how we get the angle in the second quadrant. Be 45, now comma, and subtract there, we get 135 degrees. Now from there, you see that now this angle is being multiplied by 2, meaning that we had to come and also correct our argument there. So if I'm correct this, you see that now it's 0x less 360, and so that this angle is multiplied by 2. This will be now 0 less 2x less 720. So now meaning I'm going to be going for the second time. Now for the second time, I'll be having now 360 plus 45 degrees, and then I'll be having for the third round, which will be 540 minus 45 degrees. Why? Because we know on the second revolution, if you are coming from 360, this is going to be theta plus 360, and this will be 540 minus theta. That's why I'm getting there. On the second revolution beyond 360, this one from here up here is 360. Then beyond 360, that's what I'm getting. That's how we get those angles. Now, from here, we just compute everything. So now my 2x plus 45 will be 45, comma, 135, comma. There we shall be having 4, 5. When you compute this, so when you add this one, you get 4, 0, 5. And then from there, when I subtract off the 45, I'll be having 395. So now, when we take this side, I'll be having now 2x equaling 2. This now is going to be minus here I have 0. When I get this minus now 45. When I get this minus 45, I get 95. This, I'm taking it this side. I'll be having now 135 minus 45. Then also here, 405 minus 45. Then here, 395 minus 45. So this is now my 2x will be 0. Then here, you subtract there, you get 95. Is it 90 or 95? It's 90, comma. When you subtract straight 45 from this one, you see, when you subtract 45 there, you get your 390. You subtract 45 from that. Then the other one, sorry, this one is 360. 360. Yeah, 360 because we are subtracting off the 5, we go then the 40. Yeah, 360. Then this one, when you subtract, you get 3. When you subtract off 5, you get 350. Then we divide through by x. So our x now becomes 0, 45. 5, 180. Then with this you get to divide through by. I'm getting 175 degrees. So those are the angles we have. So that's all we have in that numbers. Now for you, your task is going to be this. Now if I'm give you a hint here, this one is that you say, because sine is you say that you R, then sine of 3 theta. Now the sign is minus, this will become minus. Now alpha equaling to root 3 sine 3 theta, then minus cos 3 theta. That's how we are going to handle this, and we'll go through the process we've been seeing. That's it, members. I wish you well.